Okay, on question 21 or 31, we want to use our axis of symmetry, our y-intercept, and one of our x-intercepts to write the equation of the graph shown. Well, first off, I notice my graph. My axis of symmetry is 3. So I'm going to say 3 equals negative b over 2a. Well, let's solve for a variable. I don't like fractions, so let's multiply both sides by 2a. So we'll get 6a equals negative b. And then, so b would be negative 6a. Now let's use the standard form of our equation to find a, b, and c. I know b is in terms of a, so that's going to help us out a little bit here. So we're going to go ax squared plus bx plus c. So what we're going to do here is instead of writing b, we're going to say that's negative 6a. So I'm going to say ax squared minus 6ax. And let's put in our y-intercept. Our y-intercept is 16, so I'll go plus 16. Now we're going to put in one of our points. I like the positive point, so I'm going to replace x with 8 and y with 0 to solve for a. So in other words, we're going to say 0 equals a times 8 squared minus 6 times a times 8 plus 16. Or 0 equals 64a minus 48a plus 16. Well, 64 minus 48 is 16a. So we're going to go 16a plus 16 equals 0. We'll subtract 16 from both sides, and we'll get negative 16 equals 16a. I divide both sides by 16. A turns out to be negative 1. And that makes sense because it is a upside down parabola. So we're going to say y equals negative 1, or let's say negative x squared. Now b would be negative 6 times negative 1, which would be positive 6. So plus 6x plus 16. And there is the equation of that line. On question 32, we're going to kind of approach this the same way. Well, not quite the same way, but we're going to use our axis of symmetry. So what happens is we've got one point at 2 and 0. I've got another point over 5 and up 9. Well, I know my axis of symmetry is going to be the same distance. Notice 2 is 3 away from 5. So subtract 3, we get negative 1. So you get negative 1 and 9.